In this video, we'll be discussing concepts related to KCL, Ohm's law, and voltage divider. So I am Mohan BS, working as assistant professor in Department of EEE SJBIT. So here they've asked us to calculate what is the effective resistance, and they've also asked us to find the voltage of across each. So please read the question carefully. Across each resistance when a potential drop of 60 volt is applied between point A and point B. So point A and point B, if I have applied 60 volts, and here you should see that they have not told which terminal is positive. Is it point A terminal or point B? So in that case you can assume any orientation. So concepts requires, as discussed, series parallel, Ohm's law, and voltage divider. Step 1, let us solve for total equivalent resistance across A and B, and then let's find the potential across each passive elements. So 6 and 3, these two are in parallel. So how do we solve this? Using conventional way, 3 into 6 divided by 6 plus 3, or 6 inverse plus 3 inverse, the whole inverse. You get the answer as 2 ohms. So 6 and 3, how are they? They are in parallel. Thus the answer is 2 ohms. Right. Next, 8 and 12. So how is 2 and 18? Sorry, 2 and 18. How are they connected? They are connected in series. Thus it is 20. So 2 and 18, they are actually in series. Thus they reduce together. They form one resistance called 20 ohms. So I've represented that circuit diagram here. Now how do we solve this further? How is 20 and 5 connected? So point A is common for 20 and 5. Point D is common for 20 and 5. Thus they share common nodes. Thus we can say that they are in parallel. Thus 20 and 5 are in parallel, and the answer is 4 ohms. And now 4 and 8, they are in series. Thus the answer is 12 ohms. So the R equivalent answer for the given circuit or problem is 12 ohms. So remember not to forget writing the units also. Now as we have solved step 1 to find the total equivalent resistance, now using voltage divider, let us see how do we find the potential drop. So this is the circuit. So now to understand voltage divider, the first rule is make sure that you have one single circuit. In the sense you will have only one loop or one mesh. In the sense you will have only one. So you can see here this forms one loop, this forms one more loop, and this forms one more loop. So here we have 3 loops. So to apply, make sure that you have only one loop. Okay, so you'll understand the voltage divider in this problem. Let us see how. So 3 and 6 we had 2 ohms, 2 and 18 we had 20, 20 and 5 we had 4. Now thus we have now one loop, right? So let's not worry about the orientation of current, whether it's clockwise or anti-clockwise. That's not important now. So here if I assume the current in clockwise, I'll be marking here plus and minus. I'll be marking here plus and minus. So refer the previous videos with respect to series parallel or with respect to KCL to understand how do we mark the orientation of polarity. Now, so when I apply KVL, how do I apply? If I assume the current as I, so I'll be writing this as 4 into I plus 8 into I. So I'm seeing here first positive. I'm seeing here also first positive, and as the current after traveling through 8 ohms it hits minus 60, so I write minus 60 is equal to 0. So this method is called as passive sign convention. And then if I simplify this, I'll have this as 4i plus 8i is equal to 60. Okay, not I1, I am sorry. Or I can simply say this as I is equal to 60 divided by 4 plus 8. So I know I can add this 4 and 8, but let me retain this as it is. I'll call this as equation 1. Now, so this V1 and V2 are the voltage drops. So V1 is a voltmeter connected at positive end of one end of 4 and other end of 4. V2 is also connected at point D and point B. So what is the equation for V1? So by Ohm's law, it is simply R into I. The value of R is 4 and the value of I is simply I. So I'll call this as equation 2 now. So what about V2? So V2 is simply 8 into I, and I'll call this as equation 3. So now we know that V1 is equal to 4 into I. I substitute from equation 1 the value of I, which is nothing but 60 by 4 plus 8. Right? So this actually is your voltage divider equation. It says that main voltage, so this is your main voltage, into same resistance, that is 4 is the same resistance, divided by the sum of the resistances. Right? So I'll rewrite here. We can say voltage divider as the main voltage into the same resistance divided by the sum of the resistances. But make sure that you have only one loop here. So let us say if I had here one more resistance of 9 ohms, then what addition or subtraction should I do for my V1 equation? So I'll write here V1 would change as main voltage, that is 60, into same resistance, that is 4, divided by the sum of the resistances, that is 9 plus 4 plus 8. What about V2? V2 is again main voltage into same resistance divided by the sum of the resistance, 9 plus 4 plus 8. Or you can apply by Ohm's law. You can see here, we can say V2 is equal to 8 into I, where the updated I with 9 ohms is simply 60 by 4 plus 8 plus 9. Will land up same as it is here. So this is your voltage divider. So let's go back with the formulas that we have written here. So by voltage divider, what is the voltage drop across 4 ohms or voltage drop between A and D? It is main voltage into same resistance divided by the sum of the resistances, which is nothing but 20 volt. Now this entire thing is actually 60 volts, whereas until here, that is from this point to this point, we have just found out it is 20. So this stretch, this complete stretch is actually 60 volts, out of which from this point, from point A to point D is 20. It's obvious that from point D to point B, it would be 60 minus 20, which is nothing but 40 volts. I hope it is clear. Or you can simply use voltage divider, which says VDB is equal to main voltage into same resistance divided by the sum of the resistance, which you again land up getting 40 volts. So this is 20 and this is 40. So how we have got this 4 ohms? 8 was there as it is. So let us write down the voltage drop for 8 as 40. And now I'm saying that voltage drop across 5 is also 20. If you remember, what was our actual circuit? So we had 5 and 20. Because of 5 and 20, we had got 4 ohms. Right? So now voltage drop across 20, what is voltage drop across 4 is also same as voltage drop across 20 and 5. So 20 and 5 together forms one resistance, that is 4 ohms. And I can make sure that A and D has a 4 ohm resistance by making 20 and 5 in parallel. So thus I have written here that voltage across 5 is 20, because voltage across 4 is 20. And why have I not taken 20 resistance into account? Because if you remember, we had some other way of getting this 20 ohm. So let's see in the problem as we solve. So voltage across 5 is also 20, voltage across 8 is 40. So we have to see voltage across 6, 3 and 18. Now how we have got 20? We've got 20 because 2 and 18 were in series. I hope you have understood that how we have got 20 now and why we have not written or taken 20 into consideration to find its voltage drop. Now 2 and 18, how do we find voltage drop across 2 and 18? We have completed with this resistance 5 and 8. So now here, what is voltage drop across 5? The voltage drop across 5 is actually 20. It is as simple as I have a voltage source of 20 volts. And this is again a small loop here, you can see. So I have a small loop here where 2 and 18 are in series. 2 and 18 are in series. Right? So now again apply voltage divider. So by voltage divider, AD is 20. VCD, if I want to find, it is 18 volts. So as I told earlier, this is as same as a 20 volt voltage, right? We have found for 5 and we have found for 8. Voltage of across 5 is nothing but 20. So please don't get confused that I have scratched 5 and written. The potential drop across 5 is nothing but 20 ohms. Okay, or the internal resistance of 20 ohms is nothing but 5. We can take in other way around. If I see here, so how do I apply voltage divider for this? Main voltage is 20 into same resistance is 2 divided by the sum of the resistances. So in this loop, how many resistance can you see? This will not take into account because voltage across drop across is 20. So I have 2 and 18. So I'll add here 2 and 18. What about this? This 20 into 18 divided by 2 plus 18. So voltage across CD is 18. And similarly, if this entire length is 20 kilometers, if this is 18 kilometers, so this would be 2 kilometers, 2 volts. So now we can see for 18, we can write here as 18 volts. And so now what is left out? We have left out with only 6 and 3. And I've written as 6 and 3 here together, not separate. Why? So let's see. So how did we get this 2 ohms? We have got this 2 ohms only because 6 and 3 were parallel. Now we have got an idea that why I have written 6 and 3 in one row, not 6 and 3 in 2 rows, because 6 and 3 are parallel. Now, since they are parallel, we know voltage remains same. Now what is the voltage across 6? What is the voltage across 2 ohms? So voltage across 2 ohms, that is nothing but VAC. So this potential drop is simply 2 volts. Thus voltage across 6 and voltage across 3 will also be 2 volts. Let's take another problem. A series circuit, a resistance of 10 ohm is connected in series with 2 resistance each of 15 ohm in parallel. That means I have a 10 ohm resistance and I have, as mentioned here, I have 2 15 ohm resistance which are connected in parallel. So they have not told that how are these two connected. Have they told? Yes, they have told here. So 10 ohm is connected in series with the 2 resistance of each 15 ohm in parallel. That means the 15 ohm resistance and 10 ohm resistance are together in series. Next, what do they say? What resistance must be applied or shunned with this parallel combination? Which parallel combination they are speaking? Between these two. So that the total current taken will be 1.5 amps with 20 volts applied. So this is what they are speaking. I have to shun a resistance here in such a condition that the total current taken would be 1.5 with a 20 volt voltage drop. So since I have taken the arrow here, that means the 20 volt I have plus here and I have minus here. So let us assume the currents I1, I2 and I3. I have assumed the currents I1, I2 and I3 flowing towards 15 ohm as shown in the orientation because of the main current. So if I apply KCL at point A as mentioned, right, how do we write? So what is KCL? Current entering at a junction is equal to current leaving. So which all currents are entering and which all currents are leaving? So current entering is 1.5 current which is entering, and which all currents are leaving? I1 is leaving, I2 is leaving, and I3 is also being leaving. Right. So let's take this separately out and apply Ohm's law to understand further. Now, according to sign convention, we'll be marking here positive and here negative based on the assumed current I. So by this I can say the voltage of across 10 ohm is 15 volts. Okay. So thus I'll say that across 10 it is 15. Then what is the voltage up across 15 ohm and the unknown resistance R? It is simply 5 ohms. I hope it's been clear. Okay. Now, so I1 and I2, can we find them now? Yes. If the answer is yes, good. So 15 ohm and R, what are their voltage drop? It is 5 volts. Now I know R, right, and I know V, so I can find I1. I know R, I know V, I can find I2. Okay. So substitute. So by Ohm's law, I1 is equal to V. I can simply, I'll say V by R1. Okay, where R1 is nothing but R1 is equal to R2 as of now. So 5 by 15, we get 0.33 amperes, which is also same for I2. So substituting that in the above equation for I1 and I2, what do we get? We get I3 is equal to 0.834 amperes. Thus now we have found I3. Now we know I3 and we know 5, so we can easily find what is the value of R by Ohm's law. So we know by Ohm's law R is equal to V by I. V is nothing but 5 volts, I is nothing but I3 in this case, the value of I is nothing but I3. So we get the value of R as approximately 6 ohms. So I hope you understood the concepts of Ohm's law, KCL, voltage divider in this video. Thank you for watching the video. Please do subscribe the channel to enhance your knowledge further.